This is what exponential functions look like. If the base is greater than 1, then this is the graph. If the base is positive but less than 1, this is the graph. As long as a is greater than 1, then the limit as x approaches infinity of a to the x is infinity. Consider now the sequence a of n is 1 plus 1 over n to the nth power. And the question is, does this limit exist as n approaches infinity? If it did, that would be the same as the limit as x approaches infinity of 1 plus 1 over x to the x power. Let's investigate. If n is 1, the first term is 1 plus 1 over 1 to the first power. That would be 2 to the first power, that's 2. A of 2 is 1 plus 1 over 2 squared, which is 3 over 2 squared, which is 9 over 4, or 2.25. A of 3 would be 1 plus 1/3 to the third power, which is 4 over 3 to the third power. It's 2.370. So the next term in this sequence would be a of 4. That's 2.4414. A of 5 would be 1 plus 1 over 5 would be 6 over 5, and we raise it to the fifth power. That's 2.48832. A of 6 is 7 over 6 to the sixth power. That's 2.5216. Okay. There are reasons for this limit to be infinity. Why? Because we're raising a number that is greater than 1 to a higher and higher power, right? And if a number is greater than 1 and we raise it to higher and higher power, then we have this infinite limit. But there is also reason to think that this thing will approach 1, because we're talking about a number that's greater than 1, but not by a fixed amount. The inside is getting closer and closer to 1, and we can raise 1 to a very, very large power. It's still just 1. So there are two very good reasons for two different limits. We call that an indeterminate, right? And this is actually the type of indeterminate that sometimes we refer to as 1 to the infinity type of an indeterminate. We have gigantic forces working against each other. One wants the limit to be infinity, the other one wants the limit to be 1. Which one will win out? So this limit was troublesome for mathematicians for quite some time. As it happens, there is an interesting balance. People prove that A1 is less than equal than A2. Actually, it's strictly, but and so on. So in general, A of n is less than equal than A of n plus 1 for all n. We can look at the first few values, right? 2, 2.25, 2.37, almost 38, 2.44, 2.48, 2.52. So it was shown that this sequence is increasing. And it was also shown that for all n, A of n is less than 3. We have these two facts together, and by the second part of the Bolzano-Weierstrass theorem, a sequence like that has a limit, which is the same as a function like that has a limit as x approaches infinity. And what is that limit? It would be the least upper bound of this sequence, which is a number less than equal than 3. And since it's an increasing sequence, we know it's bigger than 2.48, it's bigger than 2.52. This limit is greater than any fixed number in this sequence. This is what we call an existence proof. We just proved that this number exists, but we didn't really produce it. For quite some time, we didn't know whether this strange limit is rational or irrational, and we ended up giving it a name. And this is one way to define the number e. One of the definitions of e is the limit of this sequence as n approaches infinity. Our calculator has a button, e to the x. It's this button with a second. It's right there. So if we want to look at e, we just have to punch in e to the x and then 1 as the power we want. So second, e to the, we enter 1, close the parenthesis, and that's e. E is an irrational number, just like pi, and it's just as famous, and it has difficult properties just like pi does. Pi and square root of 2 are both irrational numbers, but square root of 2 is kind of friendly, because if we square it, we get 2. You cannot raise pi to any power to get into an integer, and E is similarly sort of non-algebraic. We cannot raise it to a power or do anything algebraic with it to produce an integer. Such a number is called a transcendental number. So unlike square root of 2, pi and E are two very famous transcendental numbers. Thank you for watching.